I have been sent some kits again from the online shop Icstation with the question to show them to you, and I'm going to do this in this video. And here I have my favorite part. I show it first, but in the video I'll show it last. This is a portable laboratory power supply, and you can see by the sides of my hand how tiny it is. It features everything a big laboratory power supply has. It features a voltage adjustment for a very stable output, and the interesting thing, a constant current. So you can, for example, make 10 volts, 20 milliamps, which is not much, or you can make 10 volts and 200 milliamps. And so you can simulate a solar panel or run some LEDs, or better drive some LEDs with it. But I'll get to that later. Another thing I've been sent, if I find it, there it is a Class D audio amplifier, stereo, really tiny board. Look at the size compared to my thumbnail. So it's really tiny, and I've already had some fun with this, listening to some music in quite high volume. It goes really well, it works really well. I'm going to demonstrate it to you soon. And I've also been sent this driver circuit here, which is a PWM circuit, so it takes a supply voltage in a certain range. Then it has a PWM output, and it has an input for the control voltage. With the control voltage I can align the frequency from 10 Hz to 150 kHz, and it will also vary the pulse width. This is used for driving a motor, speed control, but I will show you that you can also use it for different things. So here I have it set up, but it's not wired up yet because I was making a German part before, and I have to rewire it up. So use a jumper that lets you select for the input. You can either choose 0 to 5 volts for the PWM select, or 0 to 10 volts for the PWM select. With the potentiometer you can carefully align it. It is exactly, or precisely, this is the precision. Okay, I'll hook it up and you will see what it does. Just give me a second. So it's working. Listen to the motor. You can probably hear the pulses. And I've modified it a little bit with a resistor so it can't go to 0, so that there's some little current flowing all the time to drive my small motor. Now I'm going to increase the frequency in the PWM, and you will see the motor spins. Of course I have limited it with a resistor because otherwise it goes super fast. And now I'm reducing the frequency and the pulse width. You can see that it's getting slower and slower and slower. The advantage of this PWM stuff is very obvious because, unlike on a normal transistor regulation, where the transistor just gets hot, the transistor is always switched on, switched off, switched on, switched off, and this makes the transistor stay cold. I can touch it, it's not even warm, and you can regulate the speed of a motor. You can also use it for different stuff. I mean, it's a PWM signal. I've got a small light bulb here, and I connect it between my power supply and the output from this circuit. Then I reconnect the power, and you can see it's lit up a little bit. Now if I increase the frequency and the pulse length, you can see that it's getting brighter and brighter and brighter. So you can clearly see that it's getting brighter and darker depending on how long the pulses are and how the frequency is. But of course, if you're into electronics like me, you can also make fun stuff with it. I mean, I'm not saying driving a motor is boring, but here I have an ignition coil. It's probably from a motorcycle or so. If you add pulses to this, it will produce quite some sparks. I'll show you that in the next video part. The ignition coil has been hooked up. I'm using a power transistor because, of course, the small transistor cannot handle an ignition coil. And now I'm on the lowest setting, and it's super weak. I mean, I'm not sure if you even can see an arc, but you can hear in the background it's making RF interference with my computer speakers, although this is the lowest setting, which is really weak. Now I'm cranking it up to maximum. I mean, in the limits that I've set for this device. And now let's see, it's more impressive. So you can see it does produce high voltage, and of course with high voltage it also does make noise in my computer speakers. So I am careful with this high voltage stuff. But as you can see, apart from driving motors, light bulbs, you can also drive an ignition coil. As I said, I've reduced the frequency because if I would go too high with the frequency, the ignition coil wouldn't work. But if you go higher with the frequency, you can, for example, drive a flyback transformer. But this is not the intention of the circuit. The original intention is to control the speed from a motor or a fan, and therefore it works well. I have to say that I was really having trouble getting this module to work, and so I've had to really do some stuff to get on video what I wanted to show. But if you figure around with it a little bit, you eventually get it to work. Okay, so the next thing that I'm going to show you is the stereo Class D audio amplifier. As I said, I've tested the stuff before I made this video, and with this I've listened to some music for a while, and let's explain in the next part of the video. Digital audio amplifier Class D, shown here. Okay, so I have this audio amplifier, and as you can see, it's already hooked up to a speaker. So let me talk about this audio amplifier. It's a stereo audio amplifier based on a Class D chip, and it runs with, I tested it 10 volts, I don't know what the beginning voltage is, but it goes up to 24, and currently I'm having it on 22 volts. I have the speaker here, and I've measured it. It has a little bit of weird impedance. It says 5 ohm on the multimeter, so it's a 5 ohm speaker. It requests for an 8 ohm speaker, but I have an 8 ohm speaker, but I'm not sure if it can handle the power this amp puts out. What I've done, I mean, usually you see these amplifiers, some people play music through them, and then they crank it up, and you can see the speaker cone moving and stuff. But the problem is with music, I don't want to get in copyright troubles. I've tested this before using a bus test CD with some low frequency music on it, and I really had fun with it. It goes really good. And it said for 24 volts you should cool the chip. I don't have a heatsink on it, and I'm nearly on 24 volts. And even with my test now, it will only get warm. I'm using only one channel, so I guess this counts with 2 channels, but if you want to be safe, put a heatsink on the chip. What I have here is my speaker. It can handle the power this amplifier puts out, and on the output you can see there's this tube for the low frequencies, and it's very windy, and I have the paper. And when I crank it up, you will see the paper moving, because for me this is a good way to show that there's some power going into the loudspeaker. I should buy a decibel meter for good measurements, but I don't have one, so I just show you like this. Okay, as source for a super interesting audio signal, I'm using a 50 Hz, and guess where it comes from? So this is a 50 Hz sine wave put into the amplifier. Now I'm cranking up the volume a little bit. So this is the paper. So as you can see, lots of wind going on already. This amplifier really kicks out some amps. Amplifier kicks out some amps. Sounds funny. What I'm now going to do is, I'm making a very crude power test. I know this is super unprofessional, I know this is not how you actually do it, but I want to keep this video short. I mean, I know other YouTubers who get similar amplifiers and make a 25, 30, 40 minutes video and do exact measurements with a signal generator and oscilloscope, but hey, the seller has written down some values on this amplifier, like how many power in terms of watts can it perform, so why should I measure it? I'm just trusting the seller. Oh, and by the way, before I forgot to mention it, usually most of the kits bought from Icstation come into these anti-static bags. So they are safe, and yeah, they're good. Okay, what I'm now going to do is, I have my multimeter here. Well, I have it not here, but I have it laying around. And it's a very fancy multimeter, at least for my imagination. And it can measure AC current and AC voltage, and it shows the true RMS. And what I'm going to do is, I'm going to crank it up, the amplifier, until it distorts a little bit, and then go a little bit back. Then I'm going to measure the voltage that goes into the speaker, the AC voltage. And after that, I'm going to measure the AC current that goes into the speaker, and this can be multiplied to get the power output before it distorts. I've done it before, and there is a little bit of rattling sound. I'm not sure if that's the amplifier or the speaker, but I tell you, this puts out some watts. Okay, let me just hook it up. I'm back with my multimeter hooked up, so you can see it's not millivolts, it's overloading. Okay, so this is 5 ohm speaker, and I'm measuring the voltage on the 5 ohm speaker on a 50 Hz sine wave. the whole cabinet is vibrating really strong. Okay, around here 6.2 volts. Around 6.2 volts, and it starts to slowly disturb. It could be the speaker or it could be the amplifier. And keep in mind, I'm using cheap alligator clips. These are basically new, but they are cheap and they have some loss around them. So they are losing voltage. I have some long wires to my power supply. Usually you hook this up directly to your power supply. Okay, the next thing I'm going to do, we know it's 6.2 volts until it starts slowly to disturb. I'm going to measure the current. And let's see what comes out. Back again. And please focus. Here we go. Back again, and now I'm measuring the current from the amplifier until it distorts. I'm on AC and I've hooked up my meter in series to the speaker. Now let's crank up the volume. They are about 0.9 amps. So it's putting out about 5 to 6 watts into the speaker. Keep in mind, this is not how you measure an amplifier, because I think it was advertised at 18 watts, but the first thing is I'm using the wrong speaker, the wrong impedance. I'm having these short clip leads here, and I'm not sure if it's the speaker distorting or if it's the amplifier. I would need to measure it from the oscilloscope. But hey, at least 5 watts, very much undistorted, very clear. Trust me, this thing goes really loud, especially again compared to the sides. I mean, even the old amplifiers like the TDA 2003 were around as big as my thumbnail with the contacts, and here is the whole circuit board, not much bigger. So if you need an amplifier, you should definitely have a look into this one. It's really nice and it has really some good power. Okay, now let's go to my favorite, the power supply. So this is my favorite part of the video. This is the power supply. Although it's my favorite part, I don't really know much about what I should show. Sorry. It's like a laboratory power supply, which you know are these big things that are on your desk. And this is very tiny. It has voltage adjustment, current adjustment, and it says it goes from this voltage to this voltage. I've worked with it a little bit, using it as a normal standard power supply, like using it for powering a radio or my experiments, and it works really well. The fine thing about this is, if I would find the cable, I would show you. Here it is. I can't really reach it because it's laying behind me. So you know these cables from a wall wart power supply. This one's from a small solar panel, and it fits in here perfectly. So you can just use it as a regular power supply. And I've tested it RF-wise, like I held a medium wave radio close to it when it was working, and it was rather silent. I mean, of course it does produce RF noise, hence it's a switch mode power supply, but for a power supply of this type it was rather silent. It has lots of buttons on it, like it has the select button, on off button, and this is a trip button. The only one I've yet been using was the select button. I will show you how it works in the next clip. Here it is working, and as you can see it's putting out 14 point something volts, 14.9, and it switches between volts, amps and power. And with the switch here I can choose, okay, just show me the voltage, just show me the current, depending on what I push or what I make. So yeah, I haven't really put too much attention into this switch because mainly I was just needing the voltage. Okay, what I can do is I can measure and show you how exactly the voltage is. Let's see, this was voltage or was it current? This was voltage. So now I'm 15 volts. Let's see how much 15 volts is actually. So this is 14.99 volts, pretty much 15 volts, and it's showing 15.1, 15.2. So yeah, I mean, for the price is less than 10 bucks. I think it's okay. I don't know if the meter is exactly, oops, there was a button, or I don't know if this one's exactly. Anyhow, I really like this power supply. As I said, I was using it already and I will be using it. Check out the description, you will find the links to the products there. And use the code StefanIC or StefanICs. I'm not sure if it works, but if it still works, you get to pay less money for these things. Okay, however, thanks for watching, have a nice day, and best greetings from Stefan.